topic is on the effect of microbes and soil salinity on basil plants. A little bit about me. My name is Sandra Rito-Villar. I'm a senior from Dan River High School, and the college I would like to attend is Longwood University. And there I plan to major in graphic design. Why this topic? The reason I chose this topic is because I have a personal interest in plants and how to maintain them. This experiment is important because most agricultural plants are affected by the salinity stress, which stunts the growth of the plant and causes a big problem for the agricultural production of crops. It decreases agricultural productivity, which limits the production and sale of crops. Soil salinity is a detrimental environmental factor that affects the production of agricultural crops. Soil salinity is the amount of salt that is present in the soil. It is caused by the overflow of water, which picks up pollutants such as fertilizers and is absorbed into the soil. The salinity affects the growth, development, and production of the plant because the salt in the soil absorbs the water that the plants would have received, which limits the plant's water supply. It creates salinity stress within the plant, causing the plant to become stunted. The use of plant microbes have been known to help with the growth of plants. Plant microbes help with the yield and development of the plant by breaking down and creating nutrients for the plant. Some studies examined how microbes can be used to help with the growth of crop plants and found that the microbes increased root length, root surface area, and a number of root tips, leading to an enhanced uptake of nutrients. And as a result, it improved the development of the plant, which increased the amount of leaves and yield produced. Soil microbes can importantly alleviate soil stressors by enhancing the availability of soil nutrients. The misuse of water can also affect the soil salinity, plant, and microbes by causing all three to become either overwatered or not watered enough. The misuse of water can cause an increase of soil salinity, thus resulting in the death of microbes, and then the plants not to develop well. Studies found that soil salinity is mainly caused by water content and that the water contains inorganic and organic nutrients that are absorbed into the soil, causing an increase of salinity in the soil. The increased use of water during irrigation causes an increase of salinity in the soil. When the water in the soil starts to evaporate, it dries up the water and increases the salinity by causing the salt that was in the water to rise when it starts to evaporate, which is called secondary salinization. When the water is irrigated properly, it limits the chance of an increased soil salinity and limits the amount of strain that the plant receives, which helps the plant grow. Soil salinity can also affect the biological properties of the plant. The biological properties of plant and soil that change could affect the way plant is able to photosynthesize. Since their growth becomes stunted and the plant contains less leaves, or it could change the way the soil is able to release nitrogen that comes from the decomposition of organic materials. One study found that other than the soil salinity affecting the plant, it also affects the soil microorganisms and the production of some chemical imbalances within the soil, such as nitrogen and oil production. Soil salinity is a detrimental environmental factor that affects the production of agricultural crops around the world, and there are very few studies that implement the research towards the devastating effect of soil salinity and microbes, causing the usage of microbes to help with the soil salinity to be unknown. Study is important because soil salinity is a problem that harms the agricultural community and affects the growth of the crops, and the introduction of soil microbes could help with the growth of plants in saline conditions. The lack of research led me to my research question asking how does soil salinity and microbes affect the growth of basil plants. My null hypothesis is that if the plants are being experimented on, such as having received the saline treatment or microbes, then there will be no difference in their growth compared to the control group. Since they are being tested, they should not grow as much as the control group, since the control group has nothing in it to interfere with the growth of the plants. My research hypothesis is that if the plants are given the microbes and the saline solution, then it will grow the best, since microbes are known to help with the growth of plants and are supposed to help fight off inorganic and organic materials. The dependent variable is the measurement of the plant height from the base of the stem to the tip of the stem. The independent variable is the plants that will receive the saline solution and were given the microbes. The control is the plants not given any saline treatment or microbes, and the constants are the concentration of the saline solution and the amount of water given to the plant. For my experiments, the materials that were needed were the potting soil for the plants along with 4 trays, the Rhizobium plant microbe, a concentration of 25 millimolars for the saline solution, water for the plants that are not receiving the saline solution, a meter stick to measure the height of the plants in centimeters, and a graduated cylinder to measure the amount of water or saline solution that the plants will receive. After the materials were collected, the plants were separated into 4 separate groups: a control group, a group with saline solution, a group with microbes, and a group with both saline solution and microbes. The picture to the right shows how the plants first started being planted. Each of the plants were planted with 3 to 4 seeds each in case one of the seeds didn't grow. The microbes were then mixed into the soil. All the seeds were then placed at least an inch deep and covered up. After they were covered, the soil would be watered at least 25 milliliters every 6 days. The saline solution is also 25 milliliters every 6 days. Also, every 3 days, the height of the plants were measured and recorded. The picture on the right is a couple weeks into this experiment, and you can see some of the plants starting to sprout. Here, a dot plot was created with a mean indicator to display my statistical results. The arrows are pointing at the mean indicator that are important in my statistical test, since they show the mean of the groups that either have microbes or don't have microbes. The dots on the 0 line are the plants that did not show any growth. The plants that did not contain microbes did not grow at all, unlike the ones that did have microbes. The plants that did contain microbes fluctuated between each plant. The plant that contained both microbes and the saline solution had a better growth rate than the ones that did not contain the saline solution, but did contain the microbes. The statistical test I performed to interpret the data I collected was a 2-way ANOVA. The ANOVA yielded a p-value that was less than 0.01. This allowed me to compare the mean coverage of all my groups to determine whether or not my results were statistically different. At the 0.05 level of significance, there is sufficient evidence to conclude that the plants treated with microbes and saline solution had the greatest effect on the growth of the plant. Because the p-value was less than the level of significance of 0.01, this allowed me to reject the null hypothesis. This can further be supported by the fact that the plants that did not contain the microbes did not grow at all, and the plants that only received the microbe without the saline solution did not grow as well as the ones with microbe and the saline solution. My data show that there was a significant difference in the usage of microbes on 2 different groups. My results provide evidence to suggest that it would be better for the plants to be treated with both saline solution and microbes than just microbes. However, I do believe that there should be some further testing to confirm these results. At this time, it would be rash for agronomists to implement their usage of microbes to help with the growth of plants, because this experiment could have had flaws that ended up changing the results of this experiment. Until there is further research, the exact benefits of microbes on saline soil is still unknown. In my experiment, there was a few limitations. These limitations include where the plants were grown. The plants were grown in an empty room with sunlight, since I did not have a greenhouse to grow the plant in. This could have played a factor on the growth of the plant, since the temperature of the room was not constantly regulated. Also, the plants that contained microbes grew mushrooms, which ended up killing the plant, so the final growth of the plants was 0 centimeters, and since the other 2 groups did not grow, the final growth of all plants ended up being 0 centimeters. I found that based on the results from this experiment, the microbes help with the growth of plants in salinity conditions, but how would microbes help with plants that are already salt tolerant, such as plants that are greens? There is also a possibility that the results of a salt tolerant plant would be the same as the growth of plants without being salt tolerant. While I was doing my experiment, there was a lot of things that did not go how I thought it would go, such as the growth and death of some of my plants. But it is okay for your experiment to not turn out how you would like it to. It is all just a process of trial and error. I would like to give thanks to those who helped me along this process. I would like to thank Ms. Dillon, Ms. Fain, and Ms. Saul. Ms. Dillon was so much help when it came to helping me approve my experiment. Ms. Fain helped me create the saline solution I used for my experiment, and Ms. Long with helping me with the process and materials to grow my plants. Are there any questions? Yes, Mr. Tallarico.
So I'm just curious, in your research kind of in the industry, do you see a lot of the manufacturers and farmers add microbes to the soil?
Mr. Tallarico asked if there are any, can you repeat the question?
Yeah, absolutely. So with your research in the industry, do you see a lot of, I guess, farmers and people add microbes and salt to the soil?
Mr. Tallarico asked if there are any farmers that add salt in the soil. No, the salt, it comes naturally with erosion. So microbes are usually used to help fight off the soil salinity that is caused by the erosion. Yes, Ms. McCraw.
How did you decide to water your plants every 6 days?
Ms. McCraw asked, how did I decide to water my plants every 6 days? At first, I did I practiced watering a different set of plants before and noticed that the soil was too wet for the plant to grow. So instead I cut it down, like I made the time watered longer.
Were you surprised by the growth of the mushrooms?
Ms. Collins asked if I was surprised by the growth of the mushrooms. Yes, I was surprised. I was not expecting the mushrooms to grow, which was a surprise. I'm not quite sure how they started to grow, but maybe they started to grow because the soil was moist enough to create perfect conditions for the growth of mushrooms.